Question 4, trigonometry. So at the top of page 13, the very first trigonometry bit, there's the 6 key formulas up here. 1, 2, 3, 4, 5, 6. The 2 that you need, tan equals sine over cos, and cos squared plus sine squared equals 1. You don't need this for this paper, but it's very common, the cos squared plus sine squared equals 1. But you do need the tan sine over cos. You also need these values in the table below, and we're going to need these. So the a plus b's and the a minus b's. This we're going to need straight away. The cos and the sine. Okay, so let's start from there then. We're going to prove this. So if you look at what tan a minus b is in the log tables, page 14, it just gives you the answer, which isn't very useful because we've got to prove that. So we're going to start from the beginning. So what is tan? Tan is sine over cos. So that's where we start. Keep the a minus b, keep the a minus b, happy days. What is sine a minus b? Right, we looked that up from the log table. It's this thing. Then what is k a minus, what is cos a minus b? Again, you just looked it up. They're both here. So just copy them down. Right, now we need to make our top look like their top. So we've got sine a, but we need tan a. Okay, what can we do to sine a to get tan a? Well, sine over cos would be tan. So what I'm going to do is I'm going to divide everything by cos a. I'm going to divide this by cos a, which will make this go away. I'm going to divide this by cos a, which will make this go away. And I'm going to divide this by cos a, which will turn this sine a into tan a, because sine over cos is tan. So this top sine is now tan. This cos has gone away, because I've divided it by itself. This cos has gone away, I've divided it by itself, just leaves cos b behind. And sine over cos is tan. Now, the next step is saying, okay, I need this sine b at the very, very end to be tan b. I need this sine b at the top at the end to be tan b. How can I turn sine into tan? Again, just divide everything by cos b. So I'm going to divide everything by cos b. So this cos b goes away, divide by itself. This is going to be tan now. This will be 1. Anything divided by itself is 1. And this will be tan. It just so happens that's exactly what we want. So what we want to learn this one. In a lot of the answers it just says standard proof. So it might be one to just go out and learn. Right. Right, tan 15. Now, as soon as they're giving you 15, 75, 100, 105, anything like that, it's made up of 60s, 45s, 30s. It's made up of this table back here. It's made up from there. So we can see that 60 take 45 is 15, or 45 take 30 is 15. Now, which one to choose? So we're dealing with tan. We can either do 1 take this fraction, or we can do root 3 take 1. Well, I don't want to be dealing with this fraction here, so I'm going to do 60 and 45. It would work with 45 and 30. You just have a harder time. So 60 and 45, they're nicer numbers than these two. So 60, 45. Now, notice, this is very important now, exam technique. This isn't part B. This is part 2. So we're going to have to use part 1. Because if they didn't want you to, they'd call this part B. But it's still part of A. So very, very, very important. So we're going to use the thing above that we just had, which was tan A minus B here. So we have 60 minus 45. So we just use the answer now, and we go, okay, this is my A, this is my B. Fill it into the formula that they gave you at the very top. Then look at what tan 60 is from the table, root 3. Look at what tan 45 is, 1. Look up the others, and you'll get to here. And then you're done. You're done. Just write these the other way around over the plus sign, and you're finished. Right, I think I'll just squeeze part B into this video as well. So we need to find this x value here. You can do it with the cosine rule, because this whole thing isn't a 90-degree triangle. You're just mad to. If this is x and this is x, you can use the cosine rule. It's more algebra than I was willing to do. So I broke it down the middle. I put this into my calculator. Notice that the square root is all the way across. It doesn't just stop at this 2. So it's not 10 root 2 take root 2. It's 10 square root of 2 minus root 2. So important difference. I put this into my calculator and I divided it by 2 because that then gives me this length here on this right angled triangle. I'd much rather be doing right angled trigonometry than non-right angled. But that's just me, and you can do your own way if you want. Right, so I'll put this into my calculator. I got 6, no did I got 7.6 or something like that. I halved it, so now I've got 3.8. So then I've just drawn half of the big triangle. X there, this is 22.5 now, because that's half of 45, which is at the top. So half the 45, 22.5. I'm just dealing with the left hand side. Then I label all the sides, A and C, its sine, I'll put the things in. X is at the bottom, which isn't great. If X is at the bottom, you swap it with whatever's on the left. So this sine 22.5 comes to the bottom, X goes to the top. So I just put that in, 3.8, blah, 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 blah. I didn't actually type 3.8, I typed like all of that here. I just couldn't be bothered to write it. Divide by sine 22.5. If you get an error, it's because you're not closing this little bracket here. Close the bracket. You should get exactly 10, and that's the answer.